Welcome to one and all for this today's session. We are discussing about the topics in the unit composite materials and structures of second unit. It is actually micro and macro mechanics. In the area class, we have seen micro mechanics materials approach. In today's class, we are going to discuss on mechanics of material approach in the composite materials. And here we are going to discuss mainly on the key aspects of the mechanics of materials approach and the techniques used in that and what are the applications. Mainly, we are going to discuss these three things only. The mechanics of materials approach in composite materials, it involves to analyze the behavior of individual components. Individual components in composite materials are fibers, matrix, and the interface. In this mechanics of material approach, we are going to analyze the behavior of these individual components to predict the overall properties and the behavior of the composite material. And what are the key aspects here? The key aspects are fiber mechanics, matrix mechanics, interface mechanics, laminate theory, damage mechanics, then fracture mechanics. So analyzing the fiber properties such as strength, stiffness, and failure mechanisms. So it covers in the fiber mechanics. Examining the matrix properties like strength, stiffness, and deformation behavior. These are all coming under matrix mechanics. Studying the fiber matrix interface, including the bonding, debonding, and sliding. These are all coming under interface mechanics. Analyzing the behavior of layered composites, considering the fiber orientation and stacking sequence. These are all coming under laminate theory. Then modeling damage evolution, such as cracking, delamination, and fiber breakage. So these are all coming under damage mechanics. In fracture mechanics, we are going to examine the behavior, including the crack, propagation, and toughness. So these are the key aspects of mechanics of materials approach in the composite materials. Then what are the techniques involved in that? First one is called rule of mixtures. Then micromechanics, macromechanics, finite element analysis, experimental characterization. These are all the techniques used here. So predicting the composite materials and the individual component properties. These are all coming under rule of mixtures. And analyzing the behavior of individual fibers and matrix in the representative volume element called RVE. Generally, it is called a representative volume element. This is discussed in the micromechanics. Then examining the behavior of composite laminates using laminate theory is coming under macromechanics. Then simulating the composite behavior using numerical models, it is coming under finite element analysis called FEA. Measuring the composite properties and the behavior through testing. It comes under the experimental characterization. These are all the techniques involved in that. Then we will move on to the applications point of view. Here, material selection and design. Then structural analysis and optimization. Failure prediction and prevention. Damage tolerance and repair. Multi-scale modeling and simulation. So these are all the applications in the macro mechanics of materials approach. So what are the challenges and the limitations in the macro mechanics of materials approach? Here it is called complexity of composite behavior, variability of material properties, scalability of models and results, integration with other disciplines like thermal, electrical, that kind of view we can approach. Then experimental validation and verification. So these are the important challenges and limitations in the mechanics of materials approach. So we can see the things in elaborate manner. The fiber mechanics, generally, fiber properties are discussed like strength, stiffness, modulus, Poisson ratio, and then failure strain. These are all coming under the fiber mechanics. And fiber types are carbon fibers, glass fibers, aramid fibers, and natural fibers. Then fiber architecture in the fiber mechanics are called unidirectional, then woven, braided, and short fibers. So in the fiber mechanics, we have fiber properties, fiber types of fibers, then architecture of the fiber are discussed here. In the matrix mechanics, it's a very important thing. Strength, stiffness, modulus, Poisson's ratio, and the failure strain. This is coming under the matrix properties. The matrix types are called thermoset plastics, thermoplastics, elastomeric matrices. These are the types of matrix: thermoset, thermoplastic, elastomeric matrices. Then matrix behavior to be discussed in the matrix mechanics also. In this linear, elastic, non-linear, elastic, and viscoelastic, these are all the things will be discussed in the matrix mechanics. Then interface mechanics here, fiber matrix interface properties. Here bonding strength, frictional strength, and debonding energy are elaborately discussed in the interface mechanics coming under the fiber matrix interface properties. Then interface characterization also will be done by using the techniques used in the materials of micro mechanics of materials approach discussed. Film images like scanning electron microscopy, then TEM, that is called transmission electron microscopy, and atomic force microscopy, AFM. This is called, these are the things to be used for the interface characterization. Then interface mechanics models like called shear lag, cohesive zone, then fracture mechanics. So these are all discussed in the interface mechanics of models. Then laminate theory. In laminate theory, the following things will be discussed. One is laminate properties, laminate analysis, then laminate design. These are all things in the laminate properties: in plane stiffness, bending stiffness, and thermal expansion. These are all coming under laminate properties. Classical laminate theory, this is called CLT generally, and then first order shear deformation theory, then higher order theories are coming under the analysis of the laminate. Finally, the laminate design. Here are the optimization of fiber orientation, then a stacking sequence, and then layer thickness are be concentrated in the laminate design. Finally, the damage mechanics. This is a very important analysis to be carried out for damage mechanics. In this damage types, damage evolution, then damage characterization are to be covered. In damage types, fiber breakage, then matrix cracking, delamination, and debonding. These will be coming into the damage types. Then progressive damage modeling, damage accumulation and failure prediction. These are all coming under the damage evolution. Acoustic emission and ultrasonic inspection, as well as X-ray computer thermography. X-ray computer tomography, generally called CT. This will be coming under the damage characterization. So in damage mechanics, you will have types of damage. There is damage type, evolution damage, then the damage characterization. These three are being discussed in the damage mechanics. Next, fracture mechanics. A very important chapter. It is also studied as a separate subject generally in the structures point of view. So here, fracture mechanics, what are the things generally being concentrated are fracture modes, fracture toughness, and fracture mechanics of models. These are all things. Here, like mode 1, mode 2, mode 3, like opening, sliding, and tearing. These three kind of things called fraction modes generally. Next one is a fracture toughness. That is a critical stress intensity factor, how much it is. Then critical strain energy release rate. So depending on the factors, the values, the fracture toughness will be assessed. Finally, the fracture mechanics models. That is a linear elastic fracture mechanics. Another one is the elastic plastic fracture mechanics. Then another one is called micromechanics, which has been already discussed earlier. Then macromechanics. Macromechanics, generally laminate analysis will be done, structural analysis will be done, macromechanical modeling will be done. Okay. So macromechanics, laminate analysis, structural analysis, and macromechanical modeling will be focused on here. Then finite element analysis here, 2D, 3D models, that is FEA models, 2D, 3D models, linear and non-linear analysis will be done. Then elemental types like shell type, solid and beam elements. Then material models called elastic or plastic or viscoelastic models. Like that, it will be described in the finite element analysis. Then the experimental characterization are the very important thing in the mechanics of material approach. What is the mechanical testing? In the mechanical testing, generally tension, compression, shear, flexural test, those things, those testing will be done in the experimental characterization for a mechanical testing. And thermal testing. Thermal means will be generally temperature will be focused. So thermal conductivity, specific heat and thermal expansion test will be conducted. And a non-destructive evaluation, that is generally called NDT. Here it is evaluation. NDE generally called it. It's ultrasonic inspection, X-ray, CT, and acoustic emission testing. So these are all things coming under experimental characterization. So today's class we have discussed once again. I will recall once again. So in the macro mechanics materials approach, generally how it is analyzed, and then what are the key aspects, what are the techniques used here, then applications of mechanics of materials approach, then challenges and the limitations. Those things we have learned, and elaborately we have learned what are the fiber mechanics, matrix mechanics, and the interface mechanics, the laminate theory, damage mechanics, and fracture mechanics, as well as micromechanics and the macromechanics also. Because then finite element analysis, what are the things will be focused, and experimental characterization, what are the testing, mechanical, thermal, and non-destructive evaluation. So in simple way, we have discussed all the things. Okay. So in today's class, we have discussed these things. We will discuss more on the next session with a different topic. So thank you for one and all, those who joined this today's session. Thank you.